going to do now. These questions are actually based on alpha beta, normally are set zeros of the polynomial. So this is alpha beta. It's given that zeros of the polynomial of x square minus 3x minus 2. So, and you have to find the quadratic polynomial whose zeros are, there are two parts. First part, the two zeros are 1 upon 2 alpha plus beta and 1 upon 2 beta plus alpha. So we start from here. We can answer first what we are supposed to do, that we should, we know the relation that sum of zeros is equal to minus b by a, and you know that product of zeros is c by a. So using this basic concept, so here sum of zeros, what does it mean? If I say that alpha beta are the zeros, it means that alpha plus beta, this is the sum of the zeros, and b, you can see the value of b is minus 3, so it becomes plus 3 minus minus plus 3 and 3 upon 1, so it's 3 now. And this product alpha into beta, this is c by a. Here you see that c is minus 2, so this is minus 2. So you have got the value of alpha plus beta and alpha into beta. Now we are supposed to use these values to find the quadratic polynomial whose zeros are these. So you know the general formula of finding the polynomial is x square minus sx plus p. X square, I'm just writing this here so that you can remember this, that polynomial, quadratic polynomial is k. I just mentioned k earlier also. This x square minus sx plus p. So this sx represents the sum of zeros and p represent product of zeros. So if zeros are these, in first part zeros are these, it means first we have to find the sum of these two, and then we have to find the product of these two, and we can substitute this into this formula. So first part I am now going to start. So first part is, we'll find s. S means the sum of zeros. For the new one, you see that this is 2 alpha plus beta, and this is plus 2 beta plus alpha. So we are trying to find the sum. So what can be done now here? We can use the LCM. So LCM of this will be 2 alpha plus beta, 2 beta plus alpha. So now we do the cross multiplication like this, 2b plus alpha, and this will become 2 alpha plus beta. So your numerator has been converted to beta. This is 3 beta, or this is 3 alpha. So 3 alpha plus 3 beta. And now in the base, you can see what you are supposed to do. You have to open the brackets. So you open the brackets. It can be written as 2 alpha 2 into 2 alpha into beta plus 2 alpha square plus 2 beta square and plus this is alpha beta. So ultimately you see, you take 3 common and you can write that alpha plus beta, and it's 4 alpha beta and this alpha beta, so it's 5 alpha beta, and this is 2 you take common, so it becomes alpha square plus beta square. So now you know the value of alpha plus beta is 3, you know the value of alpha beta is minus 2, but you don't know the value of alpha square plus beta square. Once if you get the value of alpha square plus beta square, then it's very easy to get the value of s. So now I'm going to show this here, that how you can calculate this alpha plus beta. You know that alpha plus beta whole square equal to alpha square plus beta square plus 2 alpha beta. So this is the identity that you know. So alpha plus beta, we use this value. So you can substitute here. This is 3 square. You don't know alpha square, so write it like this, alpha square beta square. But you know the value of alpha into beta. Alpha into beta is minus 2. So you have put here minus 2. So this is 9 and this is alpha square plus beta square, and this is minus 4. So 4, if you bring it here, then it becomes 13. This is alpha square plus beta square. So this value you have to calculate. Now you just substitute these values here. So now 3 into alpha plus beta is 3, so this is 3. 5 into alpha beta is, this value is minus 2, and plus 2, this value that you have calculated here, this is 13. So this is 13. So now ultimately you are going to get, this is 9, and this is minus 10, and this is 26. So your answer of this is 9 upon 16. So this is the value of S. Now next step is we find the value of P. P means product of these zeros. So this is 2 alpha plus beta. This is 1, 2 beta plus alpha. So you can see this, we have already calculated 2 alpha plus beta, 2 beta plus alpha. This is equal to this denominator. So we can use that value 16 directly, because already you can see that we have calculated 2 alpha plus beta, 2 beta plus alpha. The denominator was this. So use this step rather than, you know, completely opening this again showing the same way. So better you use this value. So its value is now 16. So your required equation, so required polynomial will be px. You can say this k. I gave you the formula in the beginning. This is x square minus sx plus p. So this is x square. S was 9 by 16. You can write x, and p is 1 upon 16. So this is your answer. Some of you want to take LCM, then take LCM. Otherwise, you can leave the answer here also. Now this is the second part of this of question number 1. So here we'll find first S. S means alpha minus 1. This is alpha plus 1 plus beta minus 1. This is beta plus 1. So we'll take LCM because there is no other option to go. Alpha plus 1. This is beta plus 1. And this will become alpha minus 1. This is beta plus 1 plus this is beta minus 1. And this is alpha plus 1. So we have to simplify this. Alpha into beta, this is alpha beta, and this will plus alpha minus beta and minus 1. So I am just opening the bracket here, and here it is alpha beta plus beta minus alpha and minus 1. And here you can open this. This is alpha beta. So now next will be alpha, then beta, and then 1. So you can simplify this further if you can. This you can see beta. This is plus beta, so cancelled. This minus beta. This is plus alpha. This can be cancelled by this. So you are left with alpha beta, which is 2 alpha beta. And this is minus 1. This is minus 1. So it becomes minus 2. And you can see this is alpha beta. It's, you all already know the value of this. Alpha plus beta, you know the value of this. And this is 1. So we are going to just substitute the value that we found in previous part. So we know the value of alpha plus beta from previous step, that we know in the previous step that alpha plus beta equal to 3 and alpha into beta is minus 2. So we can find this, we can substitute these values. 2 into alpha beta is minus 2. This is minus 2, and this is alpha beta, which is minus 2 plus alpha beta, this is 3, and this is 1. So we calculate this. This will be minus 4 minus 2. This is minus 6, and this is minus 3 plus 1 4. This is 2 plus 4, sorry, and this is 4, and this is minus 2. So you can see this is minus 6 upon, and this is plus 2. So you can simplify, you will get minus 3. So your value of S has come this. Now we'll find the value of P, which is the product. So alpha minus 1, alpha plus 1, you can put the bracket, beta minus 1, beta plus 1. So now you open the bracket. You have already seen how to open this. Alpha beta, and this will become minus alpha, this will become minus beta, and this will be minus minus plus 1. And this we have already calculated in the base. So this is alpha beta, alpha plus beta plus 1. So alpha beta, and you can take minus common, so it can be written as alpha plus beta, and this is plus 1, and this is alpha beta. You have already put the value, so denominator was coming 2. Alpha beta, this is minus 2, this is minus 3, this is plus 1 upon 2. So this is minus 5 plus 1, this is minus 4 by, this is minus 4 by 2. So this is equal to minus 2. I've got p as minus 2. So your final polynomial will be px. You can write it like this: k x square minus sx plus p. So you can see your value of s was minus 3. So this is minus 3x and p is minus 2. So ultimately this answer will be x square plus 3x minus 2. So these are the ways how you can solve the problem related to alpha beta. We'll get some more problems based on alpha beta.